Okay, so let us now solve for another problem, and this time we would be dealing with a problem of a projectile that is to be thrown at an angle above the horizontal. And disclaimer that this problem is to be dependent upon our answer in the previous problem. So, okay. So it is said here that from the previous number, another stone was thrown at an angle 25 degrees above the horizontal with an initial velocity of 4 meters per second. And we will now be calculating for the following. So before anything else, I will just be drawing our figure here for us to better visualize the problem. So suppose that this is now to be your stone. And in this stone, so this stone was to be thrown, was thrown at an angle 25 degrees above the horizontal with an initial velocity of 4 meters per second. So with that, our VI is to be equal to 4 meters per second. And this particular angle here is to be 25 degrees. So once again, we will now be computing for these particular values. However, since this is to be the same setup with our previous problem, so it means that this particular height here has the same height with what we have been solving last video, and that is to be this one. So negative, so I will just be storing it in my calculator. So negative 1098.9139. So with that, so this is now to be negative 1098.9139 meters. Okay, so now, so we will now be determining the time it took the stone to land to the ground. Okay, so since we already know this particular value, and once again, if we would be having a projectile motion or a projectile that we will be analyzing, we can once again segregate the solution for the x component and of course for the y component. So I will just be drawing here. So let's say that this is now to be for your x component on the left. So for the x component, so x component, and this is now to be for the y component. So for your x component, our range is basically equal to Vix times time, where your Vix or your Vx, so let's pretend that I will be changing this to Vx times time. So your Vx is to be constant throughout. So your Vix is to be equal to your Vix, and it is also equal to your Vfx. So there. And can we solve for the time using this equation? So we can solve for Vx by getting the cosine of your Vi. So we cannot, we still do not know the value for our R. And we do not know the value for our time. So with that, we have this equation but two unknowns. So with that being said, we cannot solve using this particular equation. But what about for Y? So one solution that we can make use here is to be that of your Y, or your displacement Y is equal to your VIYT plus GT squared divided by 2. So can we make use of this equation? So do we have the value for Y? So yes, this is now to be the value for Y that we have solved for in the previous problem. Do we know the value of our VIY? So not yet, but it can easily be solved by getting the sign of this VI. And what about for T? So your T, that is actually the value that we are solving for. And what about for G? So this is to be constant in our problem, and that is now to be negative 9.81 meters per second squared. So with that being said, we can now make use of this particular equation for us to solve for the time it will take to hit the ground. Okay, but first things first, let us first get the value for our Vix and our Viy. So suppose that this is now to be your Vi. So if this is now to be your Vi, which is to be 4 meters per second, and it is said in the problem that it is to be 25 degrees above. So 25 degrees, above the horizontal. So with that, this is now to be our horizontal component. So for a moment, so this is now to be our horizontal component. So this is now to be our Vx, and this is now to be our Vy. So Vix, and this is now to be our Viy. And since Vix is to be adjacent with your angle, so we would now be using cosine. So with that, and since our VI is to be this length, 4 meters per second, so hypotenuse, which is 4 meters per second, cosine 25. And in this, since this is now to be opposite from your angle, so this is now to be 4 meters per second, sine 25. So with such, so for our VIY, looking at the calculator to your left, 4 sine 25, so that is to be positive 1.6905, and take note that this is to be positive because it is going upward. And for the ease of my calculation later on, I will now be storing this value to my letter Y in my calculator. So shift store Y. So if I would be clicking alpha Y here, so that is already stored, which is 1.69047347. Okay, and as for our VIX, this is basically equal to, so 4 cosine 25. So our answer here is now to be 3.6252 meters per second. And I will once again be storing this, so shift store to X. So if I would be clicking alpha X, so this is already stored. And for me to confirm that my answers are correct, if I would be getting the Pythagorean of this, so if I would be solving for this hypotenuse, I must arrive at this particular answer. So using Pythagorean theorem, the square root of x squared plus y squared, that should be equal to 4. So there. So as you can see, it's 4. So it means that my value for VIX and VIY are correct. Okay, so going back here, since I already know the value for my VIY, so our y, so substituting known values, and for me to have space, I would just be erasing the table for the x component first. So I will just be moving this here and substituting known values. So this is now to be negative 1098. So for the value for your y, this is now to be negative 1098.9139 meters. And this is to be equal to, so what is to be the value for our VIY? So I have already stored this into y. So take note that I have stored this into y in my calculator. And for t, so for the value for t, so this is now to be the one unknown. And for g, so that is to be negative 9.81 meters per second squared divided by 2 times t squared. Okay, so with that, I will now be rearranging this in this manner. So negative 9.81 divided by 2. So what I will be doing is that I will be transposing all of this to this side. So with that, if this is now to be negative, it will become positive. So 9.81 divided by 2. So that is now to be equal to 4.905. So 4.905 t squared. So this is now to be positive. Minus yt. So yt minus 1098.9139 meters. So this is now to be equal to 0. Okay, so with that, we can once again make use of the quadratic equation. So for our quadratic equation, given, let's say, ax squared plus bx plus c is equal to 0. So for quadratic equation, x is to be equal to negative b. So negative b plus minus the square root of b squared minus 4ac divided by 2a. So as you can see, plus minus, it means that we will be having two, of course, answers here. So with that, so for T1 and T2, so using our calculator to the left, so negative b plus minus, so I would be choosing plus first, so plus square root of b squared minus 4 times a times c. So b squared minus 4ac divided by 2a, 2 alpha a. Oops, sorry. 2a. So negative b plus minus b squared minus 4ac divided by 2a. So I would be pressing calc here and I would be substituting. So what is to be the value of b? So my value of b is to be my value for y. So that is now to be negative y, I should say. So this is now to be negative y. So negative alpha y. So if you do not want to make use of this notation or this method, it is better if you would just be putting the exact value, which is negative. So for a moment, my blackboard crashed. So for a moment. Okay, so I'm back. So once again, for your value of negative y, so instead of doing it like this, you can just put the exact value, which is to be negative 1.6905. But if you want to have an exact answer up until, let's say, 10 decimal places, just do this. So once again, I will just be typing negative alpha y. So that is to be for my value for b. And for my value of a, so that is basically 4.905. So 4.905. And the value for c, that is now to be equal to negative 1098.9139. So with that, my first answer is now to be equal to 15.1413 seconds. And the other being, so if I am to change this into negative, so this is now to be negative 14.7966. However, once again, guys, that there is, we wouldn't be considering a negative value for time. So with such, we would now be choosing the positive value, which is to be 15.1413 seconds. Okay, so like before, let us make use of our calculator to our advantage. So instead of using our quadratic formula, just go to mode 5 or mode equation. So this would differ upon the calculator that you have been using. But if you are using the calculator that is very similar to mine, so mode 5, so that is to be for equation. So once again, mode, equation, 5, and 3. So this is for your quadratic. So your calculator would ask you the value of your A, B, and C. So for your A, this is now to be 4.905. And for your B, this is now to be negative. So what is to be it? So negative 1.6905. But I have stored this in my calculator in alpha y. So this is basically negative 1.6905 here. So as you can see here, negative 1.6904730047. And as for C, that is now to be equal to negative 1098.9139. So equals, so our answer here would be 15.1413, which is to be this, and negative 14.7966, which is to be this. Okay, so with that, we have already solved for the first one. So the first one is to be this time, and our answer here is now to be equal to, so time is equal to 15.1413 seconds. So there. Okay, so now let us now solve for the range of the projectile. So erasing all of this. So for the range of the projectile, so suppose once again that this is now to be, let's say, your projectile. So from this point, it traveled here up until, let's say, here. So let's say that this is now to be its trajectory. So it means that this is now to be our range. So for our range R, that is basically Vx times time. And for our Vx, once again, this is to be constant throughout. That is to be the x component of your initial velocity. And that is to be, so looking here, that is to be 3.6252, which is to be stored in my alpha x in my calculator. So 3.6252. So with that, so Vxt, so x, so this was stored in my calculator. And for the value for your time, so this is basically it. So 15.1413 seconds. So with that, so multiplying it, so alpha x times 15.1413. So our answer here is now to be equal to 54.8907 meters. So this is now to be our answer for your range. So R is to be equal to 54.8907 meters. So once again, R is equal to 54.8907 meters. Okay, so how about for its final velocity? So once again, for the final velocity, so your final velocity Vf is to be equal to the square root of Vfx squared, or its x component, plus its, of course, y component. So for its x component, that is basically x, or that is basically the x component of our Vi, because once again, the x component of your velocity would be the same throughout the trajectory. So with such, this is now to be the square root of x stored in calcu squared plus what is now to be our VFY. So for our VFY, so it wouldn't be the same with our initial VI. So for our VFY, via free falling bodies, this is now to be equal to our VIY plus GT. So with that, for our VIY, that is now to be Y. So this is to be our VIY, which is to be 1.6905. And if you can remember, this was stored in my calculator in alpha Y. So 1.6905. So Y plus negative GT, so minus 9.81, of course, times time. And our time is to be 15.1413 seconds. So with that, so Y minus 9.81 times 15.1413. So our answer here is now to be equal to negative 146.84568 meters per second. So with that, if I am to store this, so let's say store to, let's say, M. So store to M. YM, wala lang, gusto ko lang. So this is now to be for your M. So shift store M. So there. Okay, so with that, for our equation, your VF would be x squared plus M squared. So both of these are stored in my calculator. So with that, this is now to be equal to, so the square root of alpha x squared plus alpha M squared. So equal sign, so our answer here is now to be equal to 146.8904 meters per second. So this is now to be the final velocity, or its velocity before it, the moment that it would be hitting the ground, before, of course, it would stop. So this is to be the magnitude, but what about for the direction? So for the direction, so if this is now to be your y component of your VF, and this is now to be your x component, and this is now to be its resultant. So this resultant, so for your VF, this is now to be equal to 146.89. And for this one, this is to be stored in M, which is to be, so what is to be our alpha M? So VFY, so VFY was stored to M, and this is to be equal to negative 146.84568. And for our VFX, so that is to be equal to our VIX, it is also equal to our VX, and this is to be stored in X in my calculator. And that is equal to, so alpha X 3.625 meters per second. So with that, if we are now to get its angle in reference with the horizontal, if this is now to be the horizontal, we would now be getting this angle. And with such, we can just project this dimension here to this side for us to have a triangle. And we would now be projecting this particular answer here on the top. So with that, this is now to be our x, and this is now to be our m. So for this particular angle, so angle, opposite, adjacent, so the angle is to be equal to arctangent. So I'm sorry. So angle is to be equal to arctangent times opposite over adjacent. But take note that this should be an absolute value. So with such, if this is now to be, if your m is to be negative, so I would just be multiplying this by -1 just for it to be positive. So with that, arctangent of answer divided by x. So this is now to be equal to 88.59 degrees below the horizontal. Okay, so there we go. So our answer here, so for our answer for letter C, so our VF is to be equal to 146.8904 meters per second, 88.59 degrees below the horizontal. So there we have it.